What are physical quantities? Physical quantities are those which can be measured. What are the types of physical quantities? Fundamental quantities and derived quantities. What are derived quantities? Which are derived from fundamental quantities are called derived quantities. MKS, what is the difference between MKS system and CGS system? It's meter, kilogram, second, and CGS is centimeter, gram, second. What is SI system? And it is internationally accepted. Okay, universally accepted. And SI system is rational, it is coherent. There were few properties, few characteristics of SI system, right? That we had discussed. Okay. So today we'll start a discussion with dimensions. See, if I say I have drawn a line, then a line has, we say that it is one dimensional. And a rectangle and a cube. Rectangle is two dimensional, we say, and cube is three dimensional. So on this basis, we define dimensions in maths. In mathematics, we say this is one dimensional thing, this is two dimensional, and this is plane figure is two dimensional, and solid figures are usually three dimensional. We measure area in meter square. So basically, area is length cross length. The dimension of area is L2. L2, L square. Okay, if you say that we measure volume in meter cube, then dimension of volume is L cube. Okay, L represents length. So a symbol for dimensions of fundamental quantities. See, we assign symbols for dimensions of fundamental quantities. Fundamental quantities की जो dimensions होती हैं, उसको हम symbols assign करते हैं. जैसे for length, it is capital L. For mass, it is M. For time, it is T. You can write in your notebook. And for temperature, we can either write K or theta. It's our choice. Okay. And for current, we can write I or A. I is the symbol of current and A is ampere. Current is measured in ampere. So sometimes we write with A as dimension of current. Okay. So these are all fundamental quantities. So for fundamental quantities, these are the dimensions that we write. So it is a power of the fundamental unit of 1 unit of a derived physical quantity. For luminescent intensity, we write CD, and for amount of substance, we write mole. Any doubt in this? Should I move to the next slide? So on this basis, we write dimensional formula of various quantities. For example, for length, we can write L, na? For time, it is T, and for velocity, it is L upon T, LT minus 1. Okay. So dimensional formula is the expression of 1 unit of derived physical quantity. Dimensional formula of a physical quantity is, how do we write? We write like this. We write in terms of MLT. MLT. M is the mass, L is length, and T is time. Okay. And this X, Y, and Z, this represents the powers or dimensions of fundamental quantities, MLT. Okay. Clear? So let's take an example. How do you determine the dimension of speed? So step 1 is we'll write the formula for speed. It's distance upon time. Now distance is the length, right? The fundamental unit length. So we can write L for distance and T for time. Yes. So because we write in terms of MLT, so for distance only L exists, M and T, they do not exist. So we can write powers 0 for M and T. Okay. And for T, M0, L0, and T1. T means time, and time does not contain mass and length. So we can simply write M0, L0, T1. Okay. So what will you get? It's M0, L1 on single. Yes. And T is in the denominator. When it goes to the numerator, it becomes T minus 1. So it is LT minus 1. So this is how we write the dimensions. Okay. Easy. Let's take another example. Find the dimension of temperature gradient. So first we need to understand what temperature gradient is. Okay. So temperature gradient is temperature upon distance. Okay. See, if I say potential gradient, then it is potential upon distance. dV by dx. Temperature gradient is dt by dx. T by x, dt by t, dx, x is distance. Okay. So temperature, dimension for temperature is K1. We have no ml and t here. And for distance is L1. So on simplification, you'll get M0, L minus 1, okay, T0 and K1. Okay, this is how we write the dimension. Should I move to the next slide? Write the dimensions of acceleration, force, work, energy, power, charge, electric potential. Now you have to write the dimensions. Force is mass into acceleration. We'll write the dimension of mass first, and then acceleration, it's LT minus MLT minus 2. MLT minus 2. Or we should write M1 L1 T minus. Okay, this is how we write. ML, see, acceleration is LT minus 2, no? So this is M1 and this is L1, okay? So, and work done is force multiplied by displacement. So write the dimension of force first, it's M1 L1 T minus 2, and then write the dimension of displacement. So you'll get M1 L2 T minus 2. Please verify your answers. Energy and work, they are equivalent terms, right? So energy has same dimensions, ML2 T minus. Okay, and power is energy upon time. Write the dimensions of energy first. It is M1 L2 T minus 2. In the denominator we'll have T. So dimensions of power, we have M1 L2 and T minus 3. Charge is current into time. Current is charge upon time. Rate of flow of charge is current. Rate of flow of charge is current. Charge, so charge is current into time. So write the dimensions for current first. You want to write I or A? A. Okay, let's take A. And for time, it is T. So we can write M0, L0, T1, A1. Okay, electric potential. You have read this formula in class 10 only, electricity chapter. P is equal to W by Q. What is the definition? How do we define electric potential? Work done in bringing a unit positive charge from infinity to a point in the electrostatic field of given charge. Yes. So write the dimensions for work first. It's M, L2, T minus 2, and dimensions for charge is AT. Okay. Now simplify this. You will get M, L2, T minus 3, and T minus 3 and A minus 2. These are the pressure is, how do we measure pressure? Pressure is force upon area. Dimension of force is M, L, T minus 2, and that of area is L2. So what will you get? M, L minus 1, T minus 2. Easy. Now let's write for density. Density is denoted by rho, and it is mass per unit volume. Write the dimension of mass first. It is M. Dimension of volume is L minus, sorry, it's L3. Volume is L3. Okay. So we will get M1 L minus 3, and there is no T now. So you can simply write T0. You don't need to write. No need to write. But if you're writing dimensions, you should write properly. Okay. And relative density is density of substance divided by density of water. So density of substance is ml minus 3. Okay. Density of water ml minus 3. So you'll get M0, L0, T0. It is dimensionless. Okay. M0, L0, and T0. It is dimensionless. Universal gravitational constant. F is equal to Gm1 M2 by R square. And G is F R square divided by m1 m2. Okay, G is equal to f r square by m1 m2. So write the dimensions of force first. It is mlt minus 2 and dimension of r is L2 divided by m, right? So when you simplify this, what will you get? So we see we have 1m here and 2m in the denominator. So we can write m minus 1 and L is 3. 3 is minus 2. Yes. Okay. So this is how we'll write the dimensions. Now what is strain? What is strain? It is change in dimension divided by original dimension. Okay. Suppose we have a spring, length of the spring is L, and we attach a load to the spring. Then what will happen? The spring will stretch. Its length will increase. So there will be change in length of the spring. Suppose let's say that there is the changes, it changes its length by delta L. When the load is attached, its length changes by delta L. Now the new length is L plus delta L. So in this particular case, change in length is delta L, original length is L. We have a gas in a container, its volume is V and it is compressed by delta V. Then strain is change in volume divided by original volume. So this is just change in dimension upon original dimension. So in the numerator and denominator, we have the same dimensions. So it is dimensionless because when we have the same dimensions in the numerator and denominator, then we get nothing, 0, 0, right? So it is dimensionless. It has no units. It has no units. Okay. When a physical quantity is equated with dimensional formula of same physical quantity, then it is called dimensional equation. It is principle of homogeneity of dimensional formula. For example, consider V is equal to U plus AT. Okay. So you can see that in you can see both the side in both sides we have V here, V velocity on left hand side and right hand side, right? But we have this term AT. So AT should have the same dimension as that of V, because only same quantities with same dimensions can be added or subtracted. This is a rule, okay? And this rule is called principle of homogeneity of dimensional formula. We can add length to length. We cannot add length to velocity or acceleration. Length can be added to length, velocity can be added or subtracted to velocity, acceleration can be added or subtracted to acceleration. Okay, so our dimensions of V is LT minus 1, this we know. So because whether it is initial velocity or final velocity, they'll have the same dimension. Both initial final velocity, they are measured in meter per second only. We don't change the units, right? And U, dimensions of U, again it's LT minus 1. Dimension of A is LT minus 2 and that of time is T. So when you'll simplify this LT minus 2 and T, what will you get? Karan? LT minus 2 को T1 को जब simplify करोगे तो क्या मिलेगा बेटा? LT minus 1 ही आएगा क्योंकि minus 2 plus 1 हो जाएगा. Minus 2 plus 1 is minus 1. है ना? So we get the same dimension. Physical quantities on the basis of dimensions. So we have studied physical quantity in the previous class. These are the quantities which can be measured. So first, we have 4 different types of physical quantities. When we categorize physical quantities on the basis of dimensions, then we can categorize them into 4 different ways. 4 categories are there. So dimensional variable. Variable means जो vary करे और जिसकी dimension भी हो. So here we have जिसकी dimension है, it has dimension and does not have a fixed value. So dimensional variables are those which have dimensions and they do not have a fixed value. Okay. For example, force, velocity, acceleration. If they do not have a fixed value, these quantities do not have a fixed value and they have dimensions. Dimension of forces. याद कर लो साथ साथ. अंडरस्टैंड भी करना है, बट हमें ऐसे होना चाहिए कि यहाँ से क्वेश्चन पूछा, इधर से डायमेंशन सामने आ, ठीक है। फोर्स इज mlt minus 2, velocity is acceleration lt minus 2. Okay, so they have dimension, but they do not have a fixed value. So these are dimensional variables. Second category is dimensionless variable. They are variable, but they are dimensionless. We have just studied two dimensional variable in the previous exercise. One was relative density. Relative density is a variable, but it is dimensionless. And second is strain. Okay. Yes. Angle has no dimensions and does not have a fixed value. Okay. For example, refractive index, plane angle, etc. Plane angle is also dimensionless variable. Theta is equal to L by R. Plane angle is theta is equal to L by R. Okay. So L by R, dimension of L is L and that of R is also L. Okay, so L upon L, it is dimensionless. Refractive index is V1 by V2, C by V, है ना? C by V, so velocity by velocity. LT minus 1 upon LT minus 1, again we get no dimensions. Okay, so they are variable, but they do not have a fixed value and they are dimensionless variable. Should I move to the next slide? Third category is dimensional constant. ये भी किया है अभी हमने. एक कांस्टेंट किया है जिसकी डायमेंशन फाइंड किया है. यस, ठीक है. तो इट हैज डायमेंशन. डायमेंशनल कांस्टेंट हैज डायमेंशन, हैज अ फिक्स्ड वैल्यू. सी डायमेंशनल कांस्टेंट जी, इट हैज वैल्यू. Sorry, universal gravitational constant. The value of universal gravitational constant is 6.67 in 10 power minus 11 Newton meters per kg square. Yes. यही होते हैं ना. तो डायमेंशंस है, फिक्स्ड वैल्यू है, और ये क्या है? डायमेंशनल कांस्टेंट है. वैल्यू ऑफ यूनिवर्सल ग्रेविटेशनल कांस्टेंट डज नॉट चेंज. It is universally accepted. It is same everywhere. On moon, on earth, everywhere it is same. Small g varies. Acceleration due to gravity varies with depth and height, right? But capital G remains the same. Its value does not change. Okay, examples are gravitational constant, gas constant, Planck's constant, etc. You'll be studying gas constant and Planck's constant in this session. Okay. Fourth is dimensionless constant. So we have a constant and that constant has no dimensions. Any number is a dimensionless constant. 2 has no dimensions and it is a constant. Okay. So it has no dimension, and because it is a constant, see, constants have fixed values and variables do not have fixed values. It's obvious. Variables is something which varies. Okay. So constant have fixed values, variables do not have fixed values. Dimensional constant have dimensions. A dimensionless constant do not have dimensions. Dimensional variables have dimensions, but they do not have fixed value because they are variable. And dimensionless variable have no dimensions, but they are variable. They do not have fixed value. Okay, because they are variable. Okay. Example of dimensionless constant numbers like 1, 2, 3. Okay, they are dimension. Pi is a dimensionless constant. Now we have questions based on this. A unitless quantity. Unitless, which has no unit. Unitless has no dimension, maybe a physical constant without dimensions, always a number, all the above are correct. Okay, what do you say? एक सेकंड, चलो एक सेकंड तो ऑप्शन में नहीं है हमारे. हाँ जी. All the above are correct. Next, which of the following is not dimensionless quantity? Dimensionless quantity कौन सी नहीं है? Okay, angle, strain, specific gravity, density.
LCD.
And density की dimensions होती. It is not a dimensionless quantity. If the dimensional formula for the physical quantity is m1 L2 T minus 2, then the physical quantity is. See, you have not read about torque, but you know the answer. That's good. अच्छी बात है. Torque is R cross F. Okay, and it is the rotational analog of force. Okay, R cross F. So we multiply R and F. Okay, F is MLT minus 2 and R is L. So we get ML2 T minus 2. Dimension of torque and that of work. They are same, but these quantities are different. Okay, quantities are, these physical quantities are different. Torque is not work, but the dimensions are same. Okay. Physical quantities having the same dimensional formula. Sometimes they ask in exam that उसमें से 4 quantities दे दी और आपको बोलते हैं कि बताओ किनका dimensional formula same है ना? A, B, C, C, D. You get options like this. Okay. So physical quantities having same dimensional formula. Distance, displacement. Distance is measured in meter, displacement in meter, radius in meter, light year can be expressed in meter, wavelength, length of the wave, again, meter, radius of gyration in meter. Radius of gyration you'll study in rotational motion. So they all have the same dimension L. Okay. Speed, velocity of light, again, they have the same dimension LT minus 1. Acceleration due to gravity, intensity of gravitational field, centripetal acceleration, they have the same dimension LT minus 2. Impulse, change in momentum, again. Impulse is change in momentum. This you have studied in class 9 in the chapter Force and Laws of Motion, where we, in second law, we had done the rate of change of linear momentum with time is directly proportional to external force applied. F is equal to dP by dt. And F dt is equal to dP. dP is change in momentum and F dt is impulse. So impulse is change in momentum. Okay, they are related. So obvious, related and the dimensions be equal. Same only. Force, weight, and tension, thrust. They have the same dimension MLT minus 2. Weight is mass into acceleration due to gravity. It is F, W is equal to mg hota hai. F is equal to ma. A and G have the same units. Tension is the force. Thrust is the perpendicular force, right? So MLT minus 2. They all have the same dimensions. I'm going to change the slide. Should I? Writing. Work, energy, moment of force or torque, moment of couple, they have the same dimension. Moment of force is again torque, it's R cross F. Okay. Force constant, surface tension, spring constant, energy per unit area. They have the same dimension MT minus 2. Okay. Angular momentum, angular impulse, Planck's constant. They have the same dimension. Angular momentum is R cross P. P is linear momentum. Okay, tell me the dimension of linear momentum. Linear momentum is mass into velocity. Yes, mass is M. Yes, velocity is LT minus 1. So linear momentum is MLT minus 1. And angular momentum is R cross P. So we have R means L and P means MLT minus 1. Dimension क्या हो जाएंगी M. ठीक है. Angular velocity, frequency, velocity gradient, decay constant, rate of disintegration, they have the same dimension, T minus 1. It's ML2 T minus 1 here. It's not minus. Please change this. You find the dimension. Momentum is mass into velocity. It is mass into velocity is mlt minus 1. So when we multiply L with mlt minus 1, we get ml2 t minus 1, not ml minus 2. Okay, it's ml2 t minus 1. Please correct this. Stress, pressure, modulus of elasticity, they have the same dimensions. Stress is force upon area. What is stress? Dimension of force is mlt minus 2, mlt minus 2 upon L2. L2, when go to the numerator, becomes L minus 2. So it's ml minus 1 t minus 2. Okay. Angular momentum, Planck's constant, have the same dimensional formula. Electric field, potential gradient have the same dimensional formula. Surface tension, surface energy, force gradient, and spring constant have the same dimensional formula. Acceleration and gravitational field intensity have the same dimensional formula. Okay. First question is, which physical quantity is similar to dielectric constant according to dimensional analysis? Stress, strain, electric capacity, electric permittivity. Yes. See, dielectric constant is epsilon by epsilon naught. It has no units. Answer is strain. Yes. Next question. The product of energy and moment of inertia has the dimension same as the square of linear momentum, square of angular momentum, angular impulse, Planck's constant. This we have to find out. Okay, pens उठाओ अपने अपने and please write. Energy, what are the dimensions of energy? Yes. Dimension of energy is ml2 t minus 2. And moment of inertia, you know what moment of inertia is? You don't know, no? Moment of inertia is denoted by I and it is equal to mk square. This you will study in the chapter rotational motion. Okay. And what is the dimension of m? It is m. And this is radius of gyration. Okay. So L2. So product of energy and moment of inertia. What will you get? M2, L4, and T minus 2. Okay. Now this square of linear momentum. Linear momentum is P. P is equal to mv. Dimension of MP is mlt minus 1. Okay. And square of linear momentum. Square of linear momentum is m2 L2 T minus. ये तो बात नहीं बनी. ये तो बात नहीं बनी. Cross. Square of angular momentum. What is angular momentum? R cross P. Okay. So dimension of angular momentum will be L and dimension of P is mlt minus 1. Okay. So dimension of L is m L2 T minus 2. Square of angular momentum will be square of angular momentum T minus 1. T minus 1. Square of angular momentum is m2 L4 T minus 2. ये बात बन गई है हमारी. Yes. Next we have principle of homogeneity. This we have discussed. What is principle of homogeneity? Same units can be added or subtracted. Yes. Same quantities, same physical quantities can be added or subtracted. Same units can be physical quantities with same dimensions, or we can say that same units. Okay. So it states that only quantities of same dimensions which can be added, subtracted, and equated. So we can only add the quantities with same dimensions. X is equal to y plus z. So x, y, and z, they have the same dimensions. Okay. Dimensionally, x, y, and z are equal. Dimensionally, they are equal. Okay. हो सकता है कि वो physical quantities different हो, but dimensionally they are same. So S is the displacement and T is the time. Find the dimension of A, B, C and D. How will you find the dimension? Equate karoge. S is, so because S is A, T, Q plus B, T square. क्या बोल रहे हो बेटा? Yes. Okay. So this displacement has the dimension of L. This will have the same dimension L. They all have the same dimension L because length can be added to length. Okay. Dimensionally जो सेम होते हैं, dimensionally जो equal होते हैं, उन्हीं को ये मैट सब्ट्रैक्ट कर सकते हैं. तो AT cube, dimension of AT cube is L. Okay. Dimension of A will be L T minus. इसको समझ नहीं आया. because ये 80 क्यूब है ना, तो एक ही डायमेंशंस निकालनी है. And this is time, T is time, so we can write T cube and it is L. Okay, so dimension of A is L upon T, so it is LT minus 3. Okay, easy. In the same way we can find the dimension of B, C and D. करो. BT square is L. BT square has a dimension of displacement because only same dimension, dimensionally equal quantities can be added or subtracted. What will you get? You're not writing, Vinam? You've done? Show me. LT minus 2. Third, CT is L. The dimension of C is LT minus 1. And that of D is L. Okay. Verify. In a given relation, F is equal to AT plus BT square, where F and T denotes force and time respectively. Find the dimension of A and B. F is equal to AT plus BT square. Dimension of force? Yes, it's MLT minus 2. Dimension of AT will be MLT minus 2. So this implies dimension of A MLT minus 2. And dimension of BT square is MLT minus 2. And therefore dimension of B is MLT minus 2. Easy. See, uses of dimensional analysis method is to check the correctness of the given equation. Okay, on the basis of principle of homogeneity, we can check the correctness of the given equation. Okay. आपकी जो equation है, your equation should be dimensionally correct. For example, if you say B is equal to U plus AT, then AT has the same dimension as that of velocity. LT minus 1, this we have discussed, right? So we can check whether the given equation is correct or not. Second, we can convert one system of unit into another system. We can convert MKS into CGS and CGS into MKS, right? So one system can be converted into another. Third, to derive the equations showing the relation between different physical quantities. So if we say that force is dependent on mass and acceleration, derive the relation. Or if I say that force is dependent on mass and distance, derive the relation. So we can find the relation using dimensional analysis method. Okay. Next we have application of dimensional analysis. First is to convert a physical quantity from one system of unit into another. How do we convert one system of unit into another? Let's do this part only, okay? And then you can. To convert a physical quantity from one system of units to another. For example, we can convert MKS to CGS or CGS to MKS. Okay. So for the magnitude of a physical quantity remains the same, whatever may be the system of units. This we have discussed in the previous class that N1 U1 is equal to N2 U2, right? In measurement section, we had covered this. And dimensional formula of quantity Q. Be MALBTC, then N1 M1A L1B T1C is equal to N2 M2A L2B T2C. ये क्या है? नहीं आया समझ? अभी करवाते हैं. So N2 is equal to N1, so we can convert like this. अगर आप एक क्वांटिटी को, ठीक है, और एक सिस्टम ऑफ यूनिट को दूसरे सिस्टम ऑफ यूनिट में कन्वर्ट करते हैं. फॉर एग्जांपल, इफ आई से that 1 meter is 100 centimeter, then dimensions remain the same. Dimension, if I say for meter itself and for centimeter also, it is L. Okay, so L raised to the power 1, and here we have L raised to the power 1 only. Clear? If I write 9.8 meter per second square as 980 centimeter per second square, then these two numbers are different, no doubt. These two numbers are different, है ना? तो 9.8 में हमने 100 मल्टीप्लाई कर दिया, then we get 980. तो मीटर को सेंटीमीटर में कन्वर्ट कर दिया. So these two numerical factors, these two numbers are different. So these numbers are your N1 and N2. Okay, but this portion, this is meter per second square and this is centimeters per second square. They are dimensionally equal. How? Because we know that we write for meter it is L, for S square it is LT minus 2, right? And here also we'll have LT minus 2. So if we compare the dimensions, then here we have LT minus 2, then what is the value of B according to this? B is 1 and C is minus 2 here, right? There is no M now. We have no M here, we have only L and T. So B is 1 and C is minus 2. So they both have the same dimensions. Only the numerical value, this N1 and this N2, they are different.